Hey everybody, it's me. We are looking at Set A, topic A.1, which is finding perimeter and area of just some basic shapes when we draw them in the coordinate plane. This page is going to be in your OneNote, and it'll have links to this video and a PDF of filled out notes and the homework video that Mr. Burton always makes, and also an answer key, as well as, if I can get it to work, a Google form with just 1 or 2 questions that you can use as kind of a check-in. That's going to be optional, but it's there if you want it. So basically, as weird as it is to say, this is going to kind of work the same as it usually does. It's going to feel a little weird, but we're going to take a look at notes. You'll be able to pause the video to try some examples on your own, and then we'll go over those. So nothing too crazy, but you have blank notes. I would recommend trying to play this video maybe on your phone and do the notes on your Surface or something like that if you can. And let's just go for it. So our job is going to be trying to find perimeter and area of shapes like this. So I want to do just a reminder of some old stuff. We'll see if this will let me scroll up. So perimeter is just the distance around something, right? We've known that since forever. And so to find the perimeter of any sort of shape, all we need to do is find all the side lengths and add them all up. That means that some of the stuff we did last unit with finding lengths in the coordinate plane, that's going to show up here as well. For area, the shape determines how we're going to find the area inside of it. So parallelograms, which as we know includes rectangles and rhombi and squares. But for the area of a parallelogram, we're simply going to multiply base times height. Just being careful with how we use those terms. So if I choose this side as the base, it doesn't have to be the bottom, but that's the choice that I made, then the height is not going to be this distance down the side because that's slanted. The height has to be perpendicular to the base. I'll even write that over here. Height is perpendicular to the base. You can actually even kind of see like the letter H happening right there, but they definitely need to make a right angle. The reason we can get away with something a little bit quicker with rectangles is because with a rectangle, by definition, the sides are already perpendicular. So that's why you might just be thinking length times width, this side times that side. On a rectangle, that works because we already have right angles everywhere. For triangles, things work a little differently, but not by much. I'm still going to choose one of the sides as the base. It doesn't have to be the bottom. We'll see that in some other examples today. But if I choose this blue side as the base, then the height has to go through the opposite corner or vertex and be perpendicular to my base. And instead of just multiplying base times height, we're going to do half of that. I usually write it this way, 1/2 times base times height. Other people will do base times height, and then at the end they divide by 2, but obviously we know those are the same thing. And again, the requirement here is that the height you choose has to be perpendicular to whatever base you chose, and we'll see that in an example a little later. Other stuff we're going to need here, potentially, the distance formula. You know my thoughts on the distance formula. I don't like it, but maybe you do. Distance formula is just the Pythagorean theorem put in kind of insane form. We square some stuff, we add some stuff, and then we take a square root. It's just the Pythagorean theorem. It just smushes all of those steps into one hideous looking formula. But if you like it, to each his own. That is my cat running, if you heard that noise. And then Pythagorean theorem, I'm pretty sure you guys know this one by now. Pythagorean theorem applies to right triangles only, and we know a squared plus b squared equals c squared. C has to be the longest side, or the hypotenuse. Okay, so let's put this into a problem. Sorry, my cat's making a lot of noise in the background. Apologies if you can hear that. So on here, they've told me this is a rectangle. In our last unit, I might have given you the shape and said, prove to me that this thing's a rectangle. But here, I'm telling you that it is. We're just going to use that fact. Over here, this is an in your own words section. Give me one moment. I'm going to deal with this cat situation. And I'm back. So with the in your own words, we saw in the previous unit, sometimes we could get away with just counting to find lengths. But most of the time it took a little bit more work finding lengths, Pythagorean theorem. So take a moment and just think through how we determine which is which. But for me, I just always remember I can easily count stuff that goes straight across. I can easily count stuff that goes straight up and down. Pythagorean theorem, on the other hand, or distance formula, is what I'm going to need if I have slanted sides. And this rectangle, as you can see, all four sides are slanted going around. So for perimeter, I've put a reminder here about how to find perimeter, but that always works the same way. Perimeter, we're just going to add all the side lengths. And since this is a rectangle, that means it has 4 sides. Not sure if you knew that. I think we're good. So that means we need to find 4 lengths, and then we'll just add them together. So we're going to do what we did before. I could, if I had a lot of time on my hands, which I guess right now I kind of do, but if I were willing to put that time toward the distance formula, I could. I could find coordinates of A, I could find the coordinates of B, I could plug it into the stupid formula, or to find this slanted length, I can just count and then use Pythagorean theorem. Because if I go over, it's 1, 2, 3, 4, 5, 6 spaces, and then down 1, 2 spaces. And so the slanted length, the length of segment AB, it's Pythagorean theorem. 6 squared plus 2 squared equals that length squared. That's a 36 plus 4. So 40 is my length squared. And as always, our last job is to take the square root. I am not going to turn that into a decimal. I'm going to keep everything in kind of this ugly but exact form until the very, very end to be as accurate as possible. And I'm just going to work my way around. So look at my next side, side BC. And again, this blue side is slanted, so I can't count it, but I can count down and over. It's 3 spaces down, 1 space over. 3 squared plus 1 squared equals that length squared. 9 plus 1 is 10. And then a square root to get rid of that squaring in the Pythagorean theorem. And then since we know our properties of rectangles, we can save ourselves a little bit of time here. This side down here has to be congruent to side AB. So I don't have to redo that work. That other red segment is also square root of 40. If I did the work again, I could, because it's 1, 2, 3, 4, 5, 6 over, 2 up. The same work would get me that same answer. And similarly, this blue side has to be congruent to the other blue side. That's a property of rectangles, so side DA also has a length, square root of 10. So the perimeter is just going to be the sum of all 4 of those sides. For this topic, probably don't need a reminder that rectangles have 4 sides, but moving forward, it's going to be a good rule of thumb, a good strategy for us to say, okay, well, there are 4 sides, so I'm going to write 4 blanks. Perimeter, I'm going to add these 4 side lengths together. Again, for a rectangle, you probably could do that in your head. You would know that already, but moving forward, this is going to be helpful. So we had 2 red sides with a length square root of 40 each, and then we had 2 blue sides, each one with a length of square root of 10. So at this point, it becomes my calculator's job. Let's go about 2 decimal places. just because I feel like it. So I'm going to type this into my calculator. So square root of 40 plus square root of 40 plus square root of 10 plus square root of 10. And my calculator gave me a decimal right away, 18.97. However, those blue and white calculators most of you have might have given you 6 square root of 10, which is technically right. It's just not a decimal. This is actually more exact than the decimal. But remember, on those blue and white calculators near the bottom right, that toggle button is going to turn it into the decimal we want. So for perimeter, we had 4 sides, so we found 4 side lengths. We had done that in the previous unit, 1, 2, 3, 4, Pythagorean theorem or distance formula. And then we just added those 4 lengths together. For area, we need to be a little bit more cautious as we work through area because the shape matters. Since this is a rectangle, my area is going to be length times width is how you might remember it from the past, and that's fine. Or base times height, either one works, with a reminder that base and height have to be perpendicular. Well, the good news is we've already done that work. Any pair of consecutive or connected sides on a rectangle, they told me this is one, we've automatically got a right angle. So I've already really done most of the work here. I need a base times a height. I get to pick any side I want as the base. I'm going to pick one of the red sides. And again, I'm not using decimals yet, keeping it exact. And then my height just has to be a perpendicular side. Since this is a rectangle, the blue side, either of the blue sides is perpendicular to the red side. And then again, it's my calculator's job. Square root of 40 times square root of 10 is exactly 20 square units, meaning if I took all of this region in here and I kind of rearranged those little partial squares and made full squares out of them, I would find exactly 20 squares filling that area. Okay, so here our perimeter was about 18.97 units. Our area was exactly 20 units squared, or some people will write square units, doesn't matter. The squaring doesn't mean you're actually like doing any squaring, it's just that's the way that we measure stuff. Length might get measured in inches, but area, as we've talked about before, area of a region has to get covered up in little squares. So a stupid thing that I think I've shared with you guys before is the stupid word squarea. If I'm dealing with area, I'm going to use square units. Square area equals square area. So we just found perimeter and area of a rectangle. Let's do the same thing here, but with a triangle. Okay, so for perimeter, this is going to work exactly the same regardless of the shape you're dealing with. This time, a triangle, surprise, only has 3 sides. And so your job is going to be to find those 3 side lengths, just like we did for the rectangle. One of those is going to be super duper easy to find. It isn't going to take Pythagorean theorem. So what I'd like you to do is pause the video. You can hit spacebar if you're on your Surface to pause it quickly. And try to find the perimeter. And again, let's go with 2 decimal places, as we did before. Pause the video. I'm going to pause my recording. And when you unpause me, you can check your answer. And I'm back. So here we had 3 side lengths. This red side on the left didn't really take any fancy work. Definitely no Pythagorean theorem and definitely no distance formula. I just counted. It was 9 spaces down. Done. The slanted blue side required a little bit of work. I've shown that here. And the other slanted side here in green, a little bit of work. I've shown that there. To find the perimeter, I added those up. And 2 decimal places, this one I had to round up. It was 26.179, so that rounded up to 26.18. But perimeter is really always going to work the same. For area, the shape makes a difference. So let me erase this work up here so I can start area fresh. You can always go back if you need to see that work. A reminder here in the notes that when I'm finding the area, the height that I use versus the base that I use, they have to be perpendicular. They have to make a right angle, just by definition. That's what it means to be a height and a base. So what that means is I would rather avoid slanted sides, because then getting things to be perpendicular is going to be tough, right? If I have a slanted side like this blue one, well, then making sure something's perpendicular, I have to find the slope, I have to do a flip and switch, and then I have to count other slanted stuff. It's just a mess. So finding the area here, since this is a triangle, my area is half of my base times my height. Technically, I could choose any one of the sides to be the base, but this side on the left is definitely the easiest choice because I can just count. We did that a minute ago. That's just a length of 9. The other reason that it's easy, so 1/2 times 9 times, the other reason it's easy is because if I've chosen a vertical base, then my height to be perpendicular gets to be horizontal. So that's another easy one. From point A, it is 1, 2, 3, 4, 5, 6, 7 spaces to get to 9. And so since my base was straight up and down, my height could be straight across side to side, and I never had to do any Pythagorean theorem, nothing with slanted sides, nothing with slope to make it more difficult. This was pretty darn easy. So 1/2 times 9 times 7, no rounding necessary. This is exactly 31.5 or 31.5 square units. Meaning, again, that if I took some of these little partial squares inside and I rearranged those and fit them together to try to make full squares, I could get exactly 31.5 squares to fill that triangle. Then the last example is one for you to try on your own, perimeter and area of another triangle. Here, I'm just going to get us started. A triangle has vertices or corners at -4, 3, 5, 3, and 2, -4. So I'm going to get that graphed here, -4, 3, +5, 3. There's a horizontal side, that's always good news. And 2, -4. And so once again, pause the video for me and try to find the perimeter and area of that triangle, and then unpause me and see if you've got it right. You can check your answers here. I only went to 1 decimal place. Oops, sorry. If you had gone to 2 decimal places, let's see what we get. 2 decimal places, a better answer here would be 25.84. Changed my mind, I guess, after I typed that. But my 3 side lengths, 9, the easy one up here, square root of 58 and square root of 85, Pythagorean theorem on the slanted sides. I just added those up. And then for area, 1/2, because it was a triangle, I chose the easy side, the horizontal side, as my base. It happened to be on the top, that's okay. And then perpendicular, I chose a vertical side as my height, multiplied that out, and there it is. So with that, you can give the homework a shot, and like I said, there will be a link in your OneNote to just like basically a 1 or 2 question check-in so that you can test yourself on it. It's not worth a grade, but you can see how you're doing. And you can give me feedback about like, hey, I was confused about such and such. So that does it for this lesson. We'll see you next time.